Greetings to you. Welcome to Physics with Ben. Don't forget to like my videos, subscribe, and share to those that need it. Yes, as I promised in the other video series, I am here today again to help you get an A in physics. Physics experiments are very important in your getting A in physics. If I have the power, I will go around all Nigerian schools to sensitize students on the importance of physics experiments. It is quite unfortunate that we are living in a country where a good number of teachers are having challenge to teach students experiment because of ill-equipped labs all around the nation. Some labs have this apparatus, but they are not really working. And so when you want to perform an experiment, the theory and the equations and the experiment will be saying different things. In physics, when the theory, the experiment, and the apparatus are saying one thing, that is truth. In your passing WAEC and getting an A, which will give you that admission you are looking for, I want you to take this video very serious. There are three main branches WAEC always sets physics experiments. Namely, 1, mechanics, 2, optics, 3, electricity. We used to have questions under heat energy, but it has been a very long time I have not seen any question on heat energy, right? All these years. And so what you'll be seeing these days will be mechanics question 1, question 2, optics, question 3, electricity. What I'm about to do right now is question 3. I recommend this book. I'm holding my hand for you. Go get a copy. A book written by my colleague James O.J. Beginner's Guide Physics Practical Manual for Senior Secondary Schools. This book is very good. I also make use of this book. I also make use of this book. I also make use of the book you are seeing here. So for the sake of this experiment, if you open this book, page 73, you'll find this experiment. So for this year, for the sake of emphasis, any experiment you see that has the resistance box and the voltmeter or the ammeter, please study it thoroughly. You may see it in your WAEC. I am speaking from a realm of experience. Any question you see in electricity that has resistance box, resistance box combined with voltmeter, or resistance box combined with ammeter, WAEC examiners may bring questions here this year. Last year it was potentiometer experiment. This year, this is what we may experience. I want to strongly warn you guys, if you have this resistance box in your school, I want you to throw it away inside the bush. Yes. For those that are made accurately, they are okay. But this particular resistance box has so many issues in it. If you are running for any external exams and you are using this resistance box has an issue of partial contact. I don't use this for my students, not even in the training or preparation for WAEC. I recommend this resistance box to you. This resistance box has the value of 9,999 ohm. This is 100 tens, this is 1,000, 100, tens, and units. 1,000, 100, tens, and units. Right now, if you want to work with this guy, sorry, this is how it is programmed. Sorry. what am I saying? Yeah, this is it. You see, x raised to power 1, x raised to power 10, x raised, times 10 times 1 times 1000. It means that right now what you see is that this resistance box, they are all on 0, 0 right now. So what you have here is 0 ohm. The moment you go like this 1 ohm, 2 ohm, 3 ohm, 4 ohm, 5 ohm. Right now this is 0 ohm. I recommend strongly you make use of this in your school to pass your physics exam. I strongly don't recommend this. And so right now I'm going to put this guy aside. Lovely. You can't see it here throughout this experiment again. This is a guy you're going to see. A resistance box is an example of a variable resistor. We have two types of resistor. We have the standard resistor. This is one of it here. This one is having 2 ohm. WAEC always use 2 ohm standard resistors in their exams. So they will tell you wrap it, label it X or S. So in this experiment, we have labeled this guy as what? As X. So if you don't mind, we may still label it as S based on what just leave it the way it is. Just leave it the way it is. So right now, before we begin the experiment, I want to quickly tell you how to read some of this apparatus. I have told you how to read the resistance box. As it is right now, any place you see times 1, it means 1 ohm. This is 1000, watch me, 1000, 100, tens, and units. You can never use this and this and this in physics experiments because you not see a resistance whose value is this. They are always from 0 up to 9, or maximum you may use this and this, but you can't use this and this. Yes, you can use this and this. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 ohm. Now, when you want to click use 10 ohm, you put it 0 here and then you go with 1. This one means 10 ohm. That is how it is read. The next thing I want to teach you how to read is the voltmeter. The voltmeter is used in measuring potential difference in a circuit. So right now, this you are seeing 0 to 5. There are small calibrations here. So 0 to 1, we have small 10 calibrations. So how do you know the value of each small line? Simple. Divide 1 by 10. You say 1 divided by 10 will give you the value 0.1. So in case you read and this red line is touching on any part here, you just say 0.1 times that value. That is how to read the voltmeter. The ammeter. Here, the WAEC may tell you the one you're going to use. Either 0 to 1. This is 0 to 1 or 0 to 3. If they ask you to use 0 to 1, make use of the up calibration. That is 0 to 1. It means that the small calibrations here are up to 10. So 0.2 divided by 10. So 0.2 divided by 10, 0.2 divided by 10 will give you 0.02. So each small line here carries 0.02 ampere. 0.02 ampere. If they ask you to make use of 0 to 3, you make use of the down calibration. So you say 0.6 divided by 10. So 0.6 divided by 10. You have, 0.6 divided by 10. That will give you 0.06. So the value for each small line using the down calibration 0 to 3 is 0.06. This is very important in running physics experiments. So let's begin. I have told you the textbook I'm using, but I'm not using any of this for now. I am going to produce like 5 different videos on current electricity. Question number 3, WAEC this year. Watch all of them and I tell you, you are going to come out with A in physics. I want to still state that the marks you get in your experiments are never divided. If you get 50 over 50 in your experiment, you have chances of making an A B, or a C in physics. If you do your theory very well, your OBJ very well, and you run your experiment very well, then an A1 in physics becomes inevitable with your prayers. So all of you watching my channels, I wish you success in all your external exams, especially this year's exam. God bless you. So let's begin. So I want to get set with your graph sheet, because I'm going to teach you how to plot your graph sheets in this experiment. Also get your calculator set with you, and also if you have this, I want to guide you on how to go about it. I'm sorry to say this, I'm not here this afternoon, this day, to criticize people destructively, but because this is my faith, I have to say this. There are so many errors in some of these books. So the graphs sometimes are not plotted in the right way that they are supposed to be plotted. So I would like you to just, sometimes even the questions are not written correctly. But I will follow it, and if there's any error, I will spot it out. But for the sake of reference, I am making use of WAEC past questions and answers. This is year 1988 to year 2019. I am making use of, I want to treat question 19, June 1998 SSCE Physics 1 practical questions. I want to treat question number 2. In recent time, question number 3 is always electricity, but here, the question number 2 was current electricity. So, let's begin. I will take this very close up, I'll read it, and then you may screenshot from here. You may screenshot. Connect the voltmeter across the given 2 ohm standard resistor and join the combination in series with the accumulator. The resistance box X, S, and a key K as shown in the diagram. Adjust the resistance box S to 15 ohm and record the reading of the voltmeter. Repeat the values of S to be 12, 10, 8, 6, and 4 ohm. In each case, record the corresponding reading V of the voltmeter. Find the values of 1 over V in each case. Tabulate your readings. Plot a graph of 1 over V along the vertical axis and S along the horizontal axis. Determine the slope M of the graph. Also determine the intercept E on the vertical axis. Evaluate the ratio E over M. State 2 necessary precautions taken when performing this experiment. 24 marks. And then if you go up, the BI states 2 conditions under which a piece of wire in a closed electrical circuit may not obey Ohm's law. Explain why the EMF of a cell is usually greater than the PD at its terminals when the cell is used to supply current to an external circuit. 4 identical cells, each of EMF E and internal resistance, are connected in series with the resistor R, resistance R. Write down the formula for the current in the circuit. 2 marks. So all of this is 25 marks. So the first things first we are going to do here right now is to generate our table of values. The table of values is an important part of physics experiments. If you don't generate your table of values correctly, I bet you are going to get it all wrong. Your table of values carries the highest marks And so I am going to lead you on how to generate your table of values here. Follow me and let's do it together. This is the circuit diagram, and I am going to generate the table of value first. Then when I'm done, I will connect the circuit diagram, and then we'll all see. So I am going to write bold the connection diagram, very, very important, so that you can see it from that end very well. This is the connection diagram for this experiment. You have something like this. You have your 2 ohm resistor connected, a voltmeter connected across the 2 ohm resistor. And then coming down here, you have your cell, you have your key, and then you have your resistance box. This is a symbol for the variable resistor, an arrow across something like this, and then this is the circuit diagram. And so the current, this is plus and this is negative. The current will flow in this direction, up here, you come in here. This is the direction of flow of the electric current back in here when the key is made. So this is your V and this is your variable resistor. So this is the circuit diagram. This is the circuit diagram. You may screenshot this quickly. So the next line of action is for me to lead you on how to generate your table of values. Your table of values is very, very important. I will teach you how to generate your table of values. It carries the highest marks in every experiment. So let's read together. I will guide you jealously on how to do that. Connect the voltmeter across the given resistor, given 2 ohm standard resistor. So in this circuit, you have the voltmeter as one parameter. It's a voltmeter here. Yeah, there's a voltmeter here. Good. Now, you also have this here. You have S as a parameter. Your S has its values. They ask you in each case, record the corresponding value of V. So this is it here. Find this. I'm pointing where you need in this experiment. So you have your S, you have your V, you have your 1 all over V. Okay, let's move down. So your table of values will look like this, right? Table of values. Now, if you have this book with you, please pick it up. You are supposed to record your table of values here. So whatever I'm doing here, please record it here. Or I may even write it down here. Yes, I may even write it down here. So let's write table of values. You see that? Good. The next thing is you write serial number. That is the number of times the experiment will be performed. So in this case, let's count. You have 1, 2, 3, 4, 5. I count again. You have 1, 2, 3, 4, 5. It means that this experiment will be performed 5 times. So you write 1, 2, 3, 4, 5. You draw a straight line. The next parameter you have is S. S stands for what? Resistance box. In this case, it is R, but they just use S. So if WAEC use S, don't go and tell them it is R. Put the S you see there. So you write your S. Your S slash the unit in ohm. You draw this line. Good. The next thing they ask you here, they ask you to do what? To measure the voltmeter reading. So your V slash volt, you draw this line down. The next thing they ask you to find the values of 1 all over V. You put V inverse slash volt inverse. You draw your straight line. Good. I believe we are done with the parameters needed. So that is that for the table of values. So the next thing we are going to do is we are going to record 12, 10, 8. We're going to record 12, 10, 8, 6, 4 in this column. So let's record. You have 12.00. You have 10.00. You have 8.00. You have 6.00. And then you have 4.00. That is that for that. So the next thing is to connect the circuit diagram for this experiment. But before I connect the circuit diagram, I want to know something. Anytime you are recording values like this that have inverse, you record this column to 3 decimal places. Values of square root, maybe you have V inverse, you have root V, you have V square, or you have V raised to the power of 3. Anytime you have something like this, you record it to 3 decimal places. So we are going to record every value here to 3 decimal places. Good. So the next line of action is for us to connect the circuit diagram. So this is the standard resistor, 2 ohm. We place it here. This is a voltmeter. We place it here. Voltmeter is here. This guy, this is the guy here. This guy, this is the guy here. The next thing is the cell. We place the cell here, and then the resistance box we place here. So watch what I'm doing quickly. Everything is from this circuit diagram. I may place it like this, and then be watching it. So this guy, this is the guy here. This guy, this is the guy here. I'll be touching it. I'm showing you. So the resistor from here to the cell. This is it. Let's use the blue, the resistor to the cell. To the plus side of the cell. This is the plus side, so this is the plus side of the cell. Good. Now the resistor to the resistance box. The resistor to the resistance box. So this is it. The resistor to the resistance box. from here to here. So this is it. Mind you, the resistance box has no polarity. You may connect it anyhow. This is it. So we can leave it like this. The resistor, we are done with the connection of the resistor. Resistor to resistance box. That is it. And then resistor to the battery. Look at it here. Now the next thing is the key. The key is in between here. We have the key, the battery to the key. The battery to the key. Can you see that? The battery to the key, and then the last but not the least, the what? The key to the resistance box. Yes, the key to the resistance box. Yes, the key to the resistance box. Yes. So the next thing is the voltmeter across the resistor. The voltmeter across the resistor. Now you can observe that I did that. Watch, and it's reading anti-clockwise. Watch. What do you see? Anti-clockwise, meaning the connection is wrong. So we are going to change the polarity of the battery. Just interswitch the battery. Good. It is reading clockwise now. It's reading clockwise now, meaning the connection is good. It's good. So that is that for that. That is that for that. So we are done with the circuit diagram right now. The next thing is to run the experiments. I would love to stop this video here and then start another video for the experiment where I will do all the table of values and then plot all the graph. So you are going to find this video link. Just click in the description box, and then you are going to find the video link for all this series so that you don't watch them randomly. Thank you, and stay put, and don't leave where you are sitting, and then just come back to the next video. God bless you.